A couple of quick things as we go through. We have to do a quick review of our solubility rules, and then we'll move from there. So let's do this. There we go. Alright. So, of our solubility rules, this is going to play a role into how we go about doing any type of solution stoichiometry problem. Just knowing these couple of things. One, most nitrates are going to be soluble. Alkali metals are group 1A. Salts and ammonium are going to be soluble. Most of our halides or halogens will be soluble except for these three that are given to you. Silver chloride, lead chloride, or lead bromide, all those, and mercury. Those are going to be insoluble, meaning they're not going to dissolve in water. Most of our sulfates, except for barium, lead, mercury, and calcium sulfate, those are going to be insoluble in water. Some hydroxides are soluble, namely the ones that are going to form our strong bases. And most sulfates, carbonates, chromates, and phosphates are going to be slightly soluble, except those that we talked about in Rule 2, which are going to be your group 1 elements. These are going to be the soluble, or those will be soluble, in water. Now, as we look at this example of these rules, we need to be able to apply them. And so we'll get started by doing this. I don't know why it was backwards, but let's try this. We're going to look at another example here. And I'll bring the size up on this. It's a little bit easier to view. Okay. Now, it says 50 milliliters of 0.75 molar calcium chloride is mixed with 150 milliliters of 0.45 molar silver nitrate. How much silver chloride will be produced? So, step one, and what we always need to start with is we need to go in with our equation to see what reaction is taking place and how we'll actually proceed from there. So, let's see. So, according to the question, we have calcium chloride, CaCl2, plus silver nitrate. Now, because I see that I have two ionic compounds starting off, I know that this is going to be a double replacement. So my metals will stay where they are. So Ca, leave some space, Ag. Let's go ahead and make this larger so it's easy to work with. Oops, run out of space a little bit. And the partners will switch. So CaNO3 and AgCl, which we know how usually will work. Now, let's go ahead and I'm going to try to adjust this back for us. I realize it's a little bit difficult, but do this to make a little bit more space for us to work. AgNO3 yield CaNO3 2 plus AgCl. Now, of course, we need to balance this. So metals are good, but our chlorides are not. So I'm going to have to double this, and which means I'm going to end up doubling my silver nitrate. All right, now from this I need to make a net ionic equation. So my net ionic equation is going to be the things I need to focus on. In this case, it tells me that I'm making silver chloride. And why am I making this? Because silver chloride forms a solid from this reaction. So I'm going to go ahead and do my chloride ions plus silver ion yields AgCl. Now, from my equation, I know that this is actually going to be 2, 2, 2, but it still works out to be the same here. 2 to 1 to 2. Okay. Now, step 3, I need to determine the number of moles present, which is given to me in the example up above. But how I'm going to go about doing this is I'm going to take my volumes of my solutions and convert that into moles. So, let's see, 0.050 liters. This is my calcium chloride, CaCl2, and I want to determine how many moles of chloride ions I'm going to get from this. So, next thing is a 0.75 moles to 1 liter, which is how I take care of my molarity because it's moles over liters. And I know for every 1 mole of CaCl2, I get 2 moles of Cl minus. Punching this into my calculator, 0.050 times 0.750 times 2, which gives me 0.075 moles Cl minus. Now, from this, now I need to go to the next step and figure out how many moles of my silver ions will I get out of this. So, back to the same. I have 0.150 liters of AgNO3 Alright, and my concentration is 0.45, so 0.450 moles to 1 liter, and for 1 mole of AgNO3, I get 1 mole Ag plus. There we go. Again, punching that in my calculator, 0.150 times 0.450, 0.0675 moles Ag plus. Now, with this, knowing that it's a 1-to-1 ratio to make my silver chloride, I know that silver is actually going to be my limiting reactant. So I'll begin my process there. So with 0.0675 moles of Ag plus, knowing that you need 1 mole Ag plus for every 1 mole AgCl. 1 mole AgCl goes to the bottom. And I need the molar mass of silver chloride. So I'm going to end up with 143.35 grams punching this into my calculator, 0.0675, basically times 143.35, means that I'm going to produce 9.68 grams AgCl from this mixture. And that's it. Once I have my equation, figure out which one's my limiting reactant, and then use that to solve for whatever the substance is that I need. My hope is that this has been a helpful tutorial for you. Revisit at any point, email me or send me any questions that you may have, and we'll see you later. Have a great one. Goodbye.